So in this video we will study about the properties of ionic substances or ionic compound. So here this picture shows the sodium chloride, and the blue or purple color small balls are sodium ion, and the green and big balls circle shows a chloride ion. So each sodium ion is surrounded by chloride ion, and each chloride ion is surrounded by sodium ion. So this shows like this one. And so evidence of well defined structure came from the 3D structure, which is from the crystals. And all these substances or ionic compounds are brittle, means if you will hammer them they will make a amorphous powder, and they have very high melting point. They are all crystalline in structure and cleave along smooth lines. So they cleave. You can break like a sodium chloride or sea salt to see how they break. So this was the properties about the ionic compound, and let's talk about the energetics. Energy involved in the formation of ionic compound. So how the energy is formation is involved in the ionic compound. So that is called the Born-Haber cycle. Born-Haber have calculated how the energies changes when an atom convert into ions, and then ions combine to form ionic compound. So that affect on many factors. Energy of the ionic bonding. Number one is a start with the metal and non-metals element, sodium solid and chlorine gas. So this is the starting point where we have sodium solid, sodium metal solid in the form, and then chlorine in the gaseous form. So what we have to do first, we need to give some energy to make the gaseous atom. So sodium will change into sodium solid, metal will change into sodium gas, and then chlorine atom will change into chlorine element in the gaseous form, and then they further need some more energy to form the sodium ion and the chloride ion. Once they will form the sodium ion and chloride ion, they will start combining. They will start releasing that energy now to form the stable sodium chloride salt. So this is the process happen when any ionic compound form. So that is called the energy which releases, that is called the lattice energy of the sodium chloride. What is the meaning of lattice energy? We will see in the next two slide. So energetic of the ionic bond. We already discussed that making ions, ionization energy and electron affinity in the previous chapter, and it takes energy to convert element to atom, which is endothermic, means it need energy. You need to provide the energy to convert the elements into atom, and then it takes energy to create a cations, positive ions, and then energy is released by making the anions. So endothermic, it takes energy to create cations, means removal of electron is always endothermic, means you need to provide some energy. Once energy is released, and then energy is released by making the anions. When an atom takes electron, it releases the energy. So basically it is exothermic, and then the formation of the solid releases a huge amount of energy, that is exothermic. So once the sodium ion and chloride ion form, they release the energy. So this makes the formation of the salt from the element, which is exothermic reaction. So this was about the energetics of the ionic compound, and let's talk about the lattice energy. What is the meaning of lattice energy? Energy required to completely separate 1 mole of the solid ionic compound into its gaseous ion, called the lattice energy. So 1 mole of sodium chloride in the form of solid which you have the sodium salt, and if you want to convert into sodium ion and chloride ion in 1 mole each, the amount of energy released to make the ionic compound, that is it came from the bond Haber cycle. So that energy is called the lattice energy, which is required to convert sodium chloride, 1 mole of sodium chloride salt or ionic compound, into ions. So more the lattice energy will be required, so they will be more stable ionic compounds. And this table shows that what is the lattice energy of these ionic compounds. You need not to memorize this, just shows the trend that which ionic compound is more stable and which ionic compound is less stable. If you will compare all these, you can see magnesium oxide and magnesium oxide look like the highest, have lattice energy. No, this scandium nitride SCN is 7000, which is really high, and the lowest one is here calcium, no, this sodium iodide is the lowest one. So this is the very easy to convert into ions compared to any other ionic compound. And then what is the trend of the lattice energy? What is the trend of lattice energy in the periodic table? So increasing charges on the ions, lattice energy increases with the increasing charges of ions, and decreasing size of ions. So as the size of ions decreases, the lattice energy increases. The energy associated with the electrostatic interaction, and it is governed by the law. So this shows the trend of the ionic compounds lattice energy. And if we need to find out how much the electrostatic interaction is there in between the two ions, so we can use this Coulomb law to find out the interaction between them. So where is the Q1 and Q2 is the charges, D is the distance between the two ions, and Coulomb constant is there. And next is electron configuration of the ions. So main group elements loses the electron, resulting in an electron configuration of a previous noble gas. So all the, if you just look at the periodic table, so metals are here, so they have tendency to lose the electron to get the electronic configuration of most stable electron inert gases. So non-metal gain the electron, resulting in the electron configuration of the nearest noble gases. So metal have tendency to lose electron so that they can get the electronic configuration of noble gases, and the non-metal have tendency to gain the electron to get the nearest noble gas electronic configuration. Next is a transition metals do not follow the octet rule. They are like a random, and a transition metal loses the valence electron first, then lose the d electron and necessary for the given ion charges. So this was about the electronic configuration and properties of ionic compounds and ions, and in next video we will study about the covalent bonding.